Hello everyone. So today we'll be looking at the post hoc or item analysis in medical education, and this is the part two of the series on item analysis, its importance, and its interpretation. So in the last video, we discussed we discussed the key metrics that are used to evaluate item analysis, and we discussed that we have difficulty index, which is the p-value, discrimination index, which is denoted by capital D. Then we have the distractor efficiency and the point by serial correlation, which actually tells us how aligned are our items as compared to the overall test scores. And then the overall test reliability or internal consistency, known as the Cronbach's alpha. Now we'll explore these metrics individually. So we'll start off with difficulty index. The difficulty index represents the proportion of students that have answered the responses correctly. So the formula is that P is equal to the correct responses divided by the total number of responses. So what is the ideal range? So the ideal range is considered to be around 0.3 to 0.7, which actually shows us that there is maximum discrimination between high achievers and low performers. While if the p-value is more than 0.85, it means that the items are way too easy. While if the p-value is less than 0.3, it means that the items are very difficult. So as per the institutional policies are considered, for instance, the ideal range for maximum discrimination in the University of Washington is 0.5, while in Dow University of Health Sciences, items with the p-value of less than 0.2 are flagged for being too difficult. By p-value less than 0.2, it means that only 20% of the students are able to attempt it properly or attempt it correctly. So, but then there is a discussion that most of the faculty members, they say that 0.85 or 0.9 even can be acceptable if the easy items are testing the basic information, or these items are there to boost the students' confidence. So this is debatable, and some faculty, and most of the faculty members, they prefer that easy items should be given to students, and not all of the items should be difficult. So keeping with this argument, here's the evidence-based recommendations which can be used as rough estimates. So the literature says that 20% of the items, they should be very difficult items, 40% should be difficult items, 30% should be moderately difficult items, and 10% of the items should be easy items. Although having a bank which has all of these four items is very difficult to maintain and very difficult to get all of these in these percentages. So the next metric which we'll discuss is discrimination index. Now the discrimination index shows how well an item differentiates between high and low performers. And usually in this formula, so all of the students in the top group who have the correct responses are taken, and then this value is subtracted from all of the bottom group. So the acceptable range of discrimination index D is more than 0.2, while less than 0.0 indicates potential flaws. And the higher the discrimination index, the higher the D value, it means the items are discriminating between high achievers and low achievers. Now, what are the implications? If items are passed more frequently by low ability group than the high ability group, it means that they are probably flawed. So as per the institutional policy of Dow University of Health Sciences, items with a discrimination index of less than 0.1 are usually flagged or marked for poor discrimination. So another value of item discrimination is the advantage of using discrimination coefficients over the discrimination index. is that every person taking the test is used to compute the discrimination coefficients, while only 54%, that is the upper 27% and the lower 27%, are used to compute the discrimination index. So that is why discrimination index is preferred over the discrimination coefficient, because it is much more faster and much more easier and much more computable as compared to the discrimination coefficient. So another metric, this is just a sample item classification guide which has been adapted from HALADENA 2004. So it has the item less than 3 or 4 levels, and the fourth level being unacceptable or open to review. So the level 1 contains item difficulty of from 0.5 to 0.7 and the item discrimination of 0.2. These are considered with the best item statistics, and they should be used mostly in this range. While level 2 ranges from 0.7 to 0.9. Now 0.7 to 0.9 means that around 70% or 90% of the individuals have answered that item correctly, with the item discrimination of plus 0.15. And this means that these items are actually easy and they should be used sparingly. Now the level 3 is 0.25 to 0.44, and this shows that the items are difficult, with the item discrimination of 0.01. Now level 4 is less than 0.2, so it means that only less than 20% individuals are able to answer that item correctly. Or if it is more than 0.91, it means it's way too easy. So way too difficult and way too easy items are usually not recommended. So now we come to the metric of distractor efficiency, which evaluates the performance of incorrect options. So each distractor efficiency evaluates the performance of incorrect options, and each distractor should attract at least some low performing students. So there should be no distractor which has not been attempted by any of the students. Now, in terms of item analysis, non-functional distractors are those distractors that are chosen by less than 5% of the students, are not chosen at all. So usually it is recommended that medical educators or teachers, they should be aiming for around 3 to 4 effective distractors per item. So, and when are items flagged based on the distractor efficiency, when there is a single 0, means it has not been chosen by any of the students, or if there is a double 0, it means then if there are 2 distractors that have not been chosen by any of the students. Now we'll talk about the PBS, the point biserial correlation coefficient. Now it is a correlation between PBS is a correlation between item score and total score, and measures the relationship between item score and the total test scores. Now the positive values, they indicate good alignment with the overall test score, while negative values, these items then need to be reviewed. So the ranges are from -1 to +1. So more than 0.2 value indicates the good alignment with the overall test score, while negative values means that the item should be reviewed. So in terms of Dow University of Health Sciences policy, items with R less than 0.1 are flagged for poor alignment with the overall performance. So that is all for now. We'll be looking at different item analysis reports in our next session. Thank you.